Hello, my name is Argenis, and I'll be talking about the alternating series. So as you can see on the top of the paper, we see a couple of numbers: 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, and so on. So as you can see from these numbers, the sign for after each number changes from negative to positive to negative to positive, and this is what we call an alternating series. And an alternating series, you can tell that a certain series is alternating by anything with a -1 to the nth power, as shown from this summation right here. -1 to the n plus 1, and any number over here. And there are two ways to tell if this alternating series converges. So, by two ways. So, the number that we saw from the other one was 1/nth. That's what we're going to call our b sub n's. So, this is how we show two ways. First, we have to show that the b sub n's are decreasing. So, as you can see here, all the other terms after the first b sub n's are less than the first term. So, as long as it's decreasing, that's the first step. We can tell that's convergent. The second way would be taking the limit of the b sub n's. So if the limit of the b sub n's equals to 0 as n goes to infinity, then we can tell that it's convergent. So if we can tell that the alternating series is decreasing and that the limit of the b sub n's are 0, then the whole series is convergent. If not, then it will be divergent. So we're going to use an example. So we're going to take the one that we saw previously, so the 1/nth. So first we have to tell if the b sub n's are decreasing. So the 1/nth right here will be our b sub n's. And the second term would be 1 over n plus 1. So as you can see here, this denominator is getting larger and larger, meaning that this whole number is getting smaller and smaller, which proves that the number after b sub n will be decreasing. So this one will be decreasing. And the second part will be taking the limit of this, of the b sub n. So as n goes to infinity, this number keeps becoming a very large number. So as this approaches infinity, 1 over a very large number will equal to 0. So therefore, it will be 0. And since it passed both two tests, then we can tell that this is convergent by passing both of these tests. Now let's do another example. In this example, we'll be doing with different numbers. Instead of 1 over n, we'll be doing 2n plus 3 over 3n plus 4. Now first we have to see if the b sub n's are decreasing. In this case, this will be the b sub n's. So, as you can tell, we know that this is an alternating series by the -1 right here. So, we can tell that as, just like the other problem, n plus 1, this will be decreasing of the b sub n's. So, now for the second part, right here, we'll be taking the limit of this, 2n plus 3 over 3n plus 4. Now for limits, for going to infinity, we'll just take the coefficients of the highest power. In this case, it will be 2 and 3. So we'll take that. So the limit will be 2 over 3. But this does not equal to 0. So even though this the b sub n's are decreasing, the limit of the b sub n's are not equal to 0. So this diverges. Now we'll do our last problem. Sorry, n to the fourth plus 7. So as you can see again, there's a -1 to an nth power. So this is definitely an alternating series. So we can write this like this. Take the -1 out, -1 to the nth power away from this fraction to become this. Just so we can make the b sub n's more clearly right here. So same thing, we have to test if the b sub n's are decreasing. So b sub n plus 1 will be n plus 1 to the fourth plus 7, because we're continuing to add n as n goes to infinity. So from this we can tell that this denominator, as n is gradually increasing, we can tell that this number gets higher and denominator gets higher and higher, meaning this number gets smaller and smaller. So this proves that the b sub n's are decreasing. And now for the second test, so we have to tell if the limit of the b sub n's are equal to 0. So let's just take the limit of this. So as you can see, just do this limit. As n goes to infinity, this number will become infinite. So 1 over any infinite number will eventually go to 0. So this goes to 0. So this passes the decreasing b sub n's test, and this one, the limit passes equals to 0. So since this series passes both of these two tests, then that means that this is convergent. And that's it for alternating series.